Hi, my name is Rick Weisberg, owner of Oasis Water Harvesting. I'm located here in Sierra Vista, Arizona, and we just finished completing this 10,000 gallon rainwater harvesting system off of this new commercial building. The roof size is 5,200 square feet, so calculations would show that a little over 3 inches of rainwater on this 5,000 square foot roof is going to fill up this 10,000 gallon tank. Then we're going to use this water to supply the irrigation system for the entire facility throughout the year. We basically have two rainy seasons here in Arizona. Our big one is what we call our monsoon season, which is in July and August. December, January, February being our heavy, our winter rains, which are typically lighter, longer lasting type rainstorms. In the monsoon season, we can easily get an inch or 2 inches of rain in a 1 to 2 hour period, so it can come down rather quickly. And we wanted to build this system to maximize its capacity of capturing that rainwater if it does happen to come down in a short period of time. And you're going to get to see the components of this system as we walk through and show you the different components that maximize this, makes it a really low maintenance, high efficiency system. So what you're looking at here is a 5,200 square foot roof with two scuppers coming off the back side of the roof. We have the primary scupper right here, which the rainwater harvesting system is connected to. If it could not handle the amount of water going onto that system in a short amount of time, there's a backup scupper, which is about 4 inches higher, the second scupper, and that would handle any additional surge of rainwater on the roof. You'll see on this first scupper there is a short 2-inch dam I created just on the downstream side of this 6-inch pipe that will stop the water and focus it down into the 6-inch pipe, which then takes it to the pre-filter and then on into the tank. So once the water comes into the 6-inch pipe, it goes horizontally along the wall, then traverses through midair, supported by this supporting staff here, and into this pre-filter. The water on this pre-filter is going to go over the top of this high-tech filtering screen. The pores on this screen are very, very fine. It filters water down to 300. It's either 300 or 350 microns. Anything larger than that just gets sloughed off the side and then goes down into like leaves or debris or gravel, or anything larger than that will go into the overflow system. Also, if the water is going over the top of this in a bigger volume than the screen can handle, then the water just goes off the screen, goes into the overflow. But then the cleaner water drops through this fine mesh screen and comes out the bottom of this and drops into the collection surface at the bottom of the filter, and then it comes back through this 6-inch pipe into the tank. And then when the tank is full, there is a second primary overflow for the tank, which is a 6-inch pipe. And that 6-inch pipe, along with the 6-inch pipe from the filter, the pre-filter, they come together underground at a T intersection and go out as one pipe, and they go along the back side of the building all the way to the front side of the building into a retention basin where there is a pop-up spring-loaded pop-up cover that when the water gets full, it'll push that pop-up open and the water will fill that retention basin, so we can use the water again. Then there are trees and plants that are going to be in and around that basin that they can take advantage of that water. You'll notice here on these overflow filters there are some rubber gaskets. My concern with this tank is when it's full with water and it weighs 40 tons, that the weight would be, and the ground gets soft when it's wet, this tank could settle a little bit. I've done the same thing over here on the outflow of the tank where we have our valve. There is a flexible 1.5 inch, that's 1 inch vinyl pipe that's flexible that will allow the tank to settle without damaging my piping going to the pump. This here is our floating extraction outlet. So this ball is going to follow the level of the water as it fills up, and this screen is going to filter out any large debris items before they go to the pump. It also has a built-in check valve, so the water can only go this way. City water could never go this way, and there are more check valves to keep that from happening, so this tank doesn't accidentally get filled up by city water and then start overflowing. It's attached to this string, and this will follow it all the way up to the top of the tank. It's attached to this string here, so as the water is lowering in the tank, at some point it's going to stop at a preset height, which can be just easily adjusted with the height of the string there. The worst water in a tank is the bottom 4 to 6 inches. That's the worst quality water. And also the water at the surface is not of the best quality. So your water in the middle section is your best quality water. Now this right here is called your calming inlet. This is where the water coming through the pre-filter comes from the top of the tank, comes down and bubbles out of the bottom of this helper. The purpose for this is, if you can imagine, after a couple of years, all the dust that's on that roof is going to end up as sediment in the bottom of this tank in the form of a layer of mud. Without this pipe, if the tank was fairly low in water and you had a rain event where water was falling through midair from 12 feet high, it's going to stir up all that mud in the bottom, and you're going to have very muddy water for a few days until it resettles out to the bottom. With this calming inlet, that won't happen. It's going to force the water up here and just bubble out. Stops the velocity of the water.
And the floats?
These two floats serve, there's two of them. One is connected to our pump. The other is connected to the city municipal water supply in the form of what's called a master valve. So when the water's in the tank, and these are up like this, these are live, and you have electricity going to your pump, and the master valve is shut closed. When the water in this tank starts lowering, falling down, at some point, these two are going to click right there, and that's going to open the master valve, allowing municipal water, and it's going to shut off the electricity to the pump, so there's no way the pump would ever run when there's no water in the tank. That's the overflow, so when the water gets to the top of that fitting right there, it's going to overflow out. And this right here is our counterweight for that gauge you saw in the front. It's simply a float inside this metal ring, which compensates for the weight of that disc. It's outside the tank. Now just follow the water level up and down. Right here with, if ever you have to work on the pump or anything, you can shut off the water going to the system. And it's going to go through this flexible pipe. Once again, that flexible pipe is so if the tank settles, we have some give there. And it's a pretty thick, heavy-duty pipe, so it won't collapse from suction from the pump. So it keeps it open. It goes underground, comes over here, and this is the water line coming up into the pump from the tank. Very first thing it goes through is a double check valve. This is to keep pressurized water from going backwards and into the tank. So from this point on, we're at 50 psi, and from this point below, we're at 3, 4, 5 psi, whatever pressure there is coming from the tank. Double check valve, it just gives you twice the backup. There's two check valves, one on each end. Then it comes into this called a Y strainer, and this is there's a little screen in here which captures any kind of debris that somehow could have gotten through the system, goes into here, and it cleans out with this little nut valve down here. You can flush it. Goes into the pump, and there's another check valve in the pump right here. Keeps pressure from going this way, only allows pressure to go to our supply where we're headed with the water. The pressurized water comes out of the pump here at the top and goes in this direction, and we have this T assembly here for three purposes. It shows us the pressure inside the system. This is a pressure sensor, and this is a temperature sensor. And both these sensors are hooked up to the brain box, which I'll show you here in just a minute. But if for some reason the pump is running and it cannot either build pressure, or it's been running and running and running and trying to build pressure and it's heating up the water inside the pump head, then the temperature sensor will shut the pump down, or the pressure sensor will shut the pump off. This pump also has a built-in dry run protection, so in case it feels it's sucking in air and it senses that, it'll shut itself off and protect the pump. It does that on an hourly basis for 24 hours, until after 24 hours, if it's still sucking air, it shuts itself off permanently until the owner has to come out and reboot the pump and get it running again. This pump also is water cooled. It's not air cooled, so we can enclose it in a completely enclosed box, which helps us in the winter time maintaining warmth inside the box for anti-freezing properties. It also does not require a pressure tank. It uses a flow detection device. So as soon as flow is detected coming through the pump, there's a little pinwheel in here that turns, and that kicks the pump on instantly. So you don't have to wait for the pressure to drop to 20 or 25 psi for the pump to kick on. As soon as it detects flow, it kicks itself on at 50 psi and stays at that. We have a union here, so if ever we need to work on these parts, this can be unscrewed and disconnected, and we can replace or repair parts. This is a plastic check valve here that is adjustable. This is a very important little device. This requires 5 psi of pressure to open this up. Let's say somewhere down in the irrigation system we had a valve that was stuck open and water was dripping out of it all the time, and the pump was shut off. The pressure from the tank, without this here, could drain the entire tank down and into our irrigation system and drain the tank of water. So that is our check valve, keeping water from going back that way. Then the water will come down here, goes underground, comes over here, and enters into our water meter for the rainwater harvesting. You can see at this time it's completely zeroed out because we haven't really hooked up any water in the tank yet. So the pump is not turned on yet. We have no water in the tank. So right now the water is only coming from the city water supply. So as we talked about earlier in the brain box, which we will show here in a moment, when there's no water in the tank, it opens. This is your master valve, which allows city water into the system. And then because of these check valves, your water can't go back and up and into the tank. It can only go towards the irrigation valves and system, which is what it's doing right now. It's actually watering some newly planted trees and shrubs around this building. And then once again, it goes through a dual check valve here, so the water can only go in this direction, can't go back this way. And then it runs underground, and over here to the right is the irrigation control box with the irrigation timers in it. So this is the inside of the brain box. We've got the 110 volt power coming in here, and then we've got our 110 volt going out to the pump right through these black and white wires. And then we've got all of our various wires coming in from various sensors. The first two there on the left are the 2 wires coming from the master valve. And then we've got this next 2 are is the float switch that's dedicated to the water level in the tank and turning on the alternate water source, which would be the master valve, turning that on or off. The next 2, the middle 2, are the 2 wires coming from the irrigation control master valve terminals. So this box is linked to the irrigation control box, and they work back and forth together. The next 2 wires are the ones coming from the temperature sensor. So if the water in that pump gets too hot, it's going to turn off the pump right here. It'll disconnect the wire, the electricity going through these wires to the pump. And these last 2 wires are for the float switch for the pump itself. This will turn the electricity off to the pump and not allow it to run accidentally and damage the pump if the water is low inside the tank. This is an adjustable on-off unit so you can determine how long you want the pump to run when the last valve shuts down on the irrigation system. The purpose for this is because irrigation valves, they need pressure to close themselves completely and to seal themselves before the system shuts down. Without that pressure, your valve wouldn't seat and wouldn't seal itself, and so you could get leakage through that valve. So you can adjust this up to, I believe, a minute length in time. Once the last irrigation valve shuts down, the pump continues to run for up to a minute, making sure everything is sealed before the pump shuts itself off.